Okay, well, again, so please keep eating. Feel free to get up and move around. And if you're just really not in the mood to listen and talk and want to go for a walk, go ahead. But we're going to spend the next, time until 2 p.m., an hour and 15 minutes, really in a focused discussion on soil moisture data quality and needed metadata. And so these are, again, two companion projects. We've got some wonderful PIs managing for us. Nandita Gaur is managing the data quality document production, and then Brianna Wyatt, the metadata document production. So we're going to start with the presentation by Nandita on her side, and then Brianna will come afterwards, and then we'll open it up for general conversation. If you have specific questions along the way, of course, after Nandita speaks, we can have those, but then again, we want a discussion later. So Nandita, if you're ready, here we go.
Good afternoon, everyone. And I hope you're all enjoying your lunch. I'm going to try and keep this not boring, but if you get bored, you can obviously go back to lunch and just not listen. So I am Nandita Gaur. I'm from University of Georgia. Before I start, I'd want to acknowledge my co-principal investigators on this project, Matthew Levi and Pam Knox, who are also here in the audience. And also a huge shout out to Todd Carville, Mike Kosh, and Marena for really driving this effort. So what I'm going to present today is a draft version of the soil moisture data quality guidance document that I'm putting together, but with a lot of community feedback, and I'll go into the process in just a bit. And I have a picture of our technician down a hole installing sensors. And I put that here because when I started out with wanting to write this document, I was like, a month, that's all I need. I'm going to get this done. Not original research, how much time can it take? But it's really like going down that hole. It starts up nice and bright, and as you keep going deeper and deeper, it gets really dark, and it's like, oh, where am I? So I'm going to use today as an opportunity to get feedback. And obviously, if you need time, there's a lot of information that I'm going to throw out at you. Possibly, you can always email either me, Matt, or Pam, and we'll work on that together. So what I'll do today is I will talk about the motivation for this document, purpose and scope, and Marina's kind of gone over this in the morning today. I'll go over the process overview, how we are developing this document, talk about the current status, where things lie, give you a document outline, which is really going to be information intensive, but the kind of things that I want you to think about and critique me on is, if it's covering everything, is this too much? Do we not have enough to say what we're trying to say in this, or we need more? So maybe think along those lines, and then we'll leave it open for discussion. So just starting out with the motivation, this is obviously an effort that's sponsored by NIDIS. And I think it responds to two recommendations made by the strategy document, which is one, to develop a set criteria for high quality soil moisture data sources, and then also support research necessary to develop or improve NCSMMN methodologies. The purpose and scope, and we thought a lot about this. So while the purpose is a little straightforward, one, it's to develop guidelines for state mesonettes or state or county level soil moisture networks, and I've highlighted that, and I'll talk about that in a bit. But just to develop guidelines to produce and report high quality soil moisture data. And then the second one, perhaps, which is most interesting, is to define tiers of quality for soil moisture data that is being produced by so many diverse soil moisture stations all over. And I've sort of underlined state mesonettes and state and county level soil moisture networks, because we do talk about station siting in this document. And that really changes if you change the scale at which you want to install these moisture stations. So just highlighted state mesonettes there. What we hope to be the outcome of this document is for state mesonette operators or anyone who's wanting to install a long-term soil moisture monitoring network to be able to select a site that is appropriate for soil moisture, select site appropriate soil moisture sensing technology, being able to understand what sensor to use, determine site suitability for soil moisture monitoring, identify and describe ancillary data like temperature, precipitation, etc., that is required for soil moisture measurements, have access to a range of QA/QC protocols to assess quality of collected soil moisture data, at least have some guidance for calibration strategies for different sensors, review commonly encountered problems and suggested solutions that many mesonet operators face. And then finally, we want the operators to be able to self-classify the quality of data that they're producing. So how we are putting this document together, obviously Nidus funded this project, and then Mike helped create a data quality working group. I see a lot of people who've been attending those online meetings for 6 months right here in this conference. So thank you for all your input. So we've met over about 6 months from February 23 to July 2023, and we've gone over various topics that are going into this document. Finally, in the last meeting, we also identified chapter leads who've actually contributed to a lot of text in the document. So they've written up text, and I've incorporated all of their feedback into the document. So what I'm going to show you now is the draft version of that document. The link to that document is here, and Marena said she can share that with you later. So if you don't have enough time for feedback today, you're more than welcome to go onto that Google Doc, leave comments, put your name on there, just so that we can acknowledge people based on how much they're contributing. So the way I look at it, and this could be part of the motivation, is what is causing variability in soil moisture monitoring and reporting? And I may be preaching to the choir, but I still want to summarize what is causing this variability. One, I think all these soil moisture stations, they've been installed or they've been funded by diverse stakeholders. So their needs vary, and consequently the units in which soil moisture is reported, or the kind of sensors that are plugged in, the orientation in which soil moisture sensors are installed, they're all different. And this kind of variability comes because we have different stakeholders to whom these moisture networks are responding to. Another thing is soil moisture sensors tend to be add-ons to weather networks. So sometimes there's not a whole lot of thought that goes into it. Obviously, everyone understands the importance of soil moisture, but there's no standard guideline onto where they're installed and how they're installed. And then personnel handling soil moisture data may or may not be trained for it, because a lot of these soil moisture long-term monitoring networks were not really soil moisture monitoring networks. Soil moisture was sort of an add-on. So I think this leads to a lot of chaotic variability in the way we are collecting and reporting and producing soil moisture data. This chaotic variability, I think, if we wanted to do some sort of standardization so that if you're using moisture from one station, you can make sense of it anywhere else, and there's some level of standardization in terms of how to understand or interpret that data, we need to reduce that chaotic variability. And that we could do if we have this guidance document. So just going into a little more detail into different aspects in which I think this variability exists. One, space-time distribution of soil moisture that is monitored. Is it representative? Where the sensors are installed, do they tell us everything we want to know about, say, the root zone or the surface? Is it integrating the soil moisture the way it should be? Accuracy and support scale of sensors, and that varies if you're using different sensors. The support scale, what you're measuring itself may be a little different. Units in which soil moisture is being measured, reported, and needed, all of those are variable. Sometimes we have volumetric soil moisture that is being measured, reported. Other times it may not be useful and you probably need plant available water content or something like that. So there's variability in units that information is required. Soil moisture sensors that are available and suitable for different conditions, high clay environments versus not high clay environments, et cetera, et cetera. Those are variable. Methods to produce useful data in a quality controlled data environment. There's no real guideline on that. So QA/QC, there is no standard guideline for that. And we hope to address that through this document. And then frequency of measurement, processing, disbursement of soil moisture data. Do you scan every 5 minutes, report every 30 minutes? Do you scan every hour? Do you scan every 30 minutes? There's no clear standardization. So if we had some sort of uniformity on that, that may help us make better use of the moisture data that we're collecting. So here's the document outline. And again, I've got the link to the document right here. So you'll all have an access to that. But chapter 1 is basically introduction and objectives, and I've kind of gone into that. Chapter 2 is a review of current QA/QC procedures that different state Mesonettes are following. And we'll go into more detail later. Chapter 3 talks about stakeholder data needs, because we are in the end responsible to different stakeholders, and we've identified key stakeholders for soil moisture data. So we've made a table for that. Chapter 4 is perhaps where we would want to discuss a whole lot, site considerations and sensor selection. So site representativeness, that was a big thing that came out in our working group meetings. Chapter 5 is quality control and quality assurance of soil moisture data. Some Mesonettes are doing a great job already, and I've incorporated a lot of literature from them regarding that. Chapter 6 is post-deployment strategies, and I confess we've made no progress there, but that's on there. Chapter 7 is data quality tiers of soil moisture data, which is perhaps again where we need discussion. And then we have 3 appendices, or we're proposing to have 3 appendices. Appendix A is a show and tell using Georgia soils. Matt Levi is leading that, and I'll kind of show you a little bit of that. Appendix B is just a copy of the survey that was sent out, and Appendix C would be quick checklists that a Mesonet operator, if they didn't want to read the whole document, they'll be like quick checklists that they can refer to. So that's the kind of outline of the document that we've decided upon. And I'll start with chapter 2 first, just going into what that is. So chapter 2 is a review of the current QA/QC procedures. Pam Knox sent out a Google form through her AASC network, and we shared this in the soil moisture data quality working group. It is a fairly involved form. For people who filled that out can attest to it. And we collected what people are currently doing in terms of QA/QC. We collected information on what their aspirational practices are. And we also collected information on what they need or what prevents them from implementing those aspirational practices. And we got a whole suite of answers ranging from lack of personnel, lack of information. So all of that data has been collected from these 16 participating networks who actually filled those forms out, and we're consolidating that information yet. If you run a long-term monitoring network and you would like to fill this form out, there's a link to this form also on this page. So please go ahead and fill that out. I think the more information we have, the better we can summarize it. So the idea in this chapter is to categorize QA/QC practices used by different networks based on, say, sensor types that they've installed, installation conditions, horizontal versus vertical, orientation of sensor installation, how often are they producing data and reporting that data latency, and geophysical characteristics of sites. So these are the different categories based on which we think QA/QC procedures may need to be tweaked. And that is why we're going to see, based on everything that people are doing, if we categorize them based on these categories, what jumps out at us. So that's one exercise. The second part is going to be a discussion of resources on what needs to implement this QA/QC strategies, so that if someone else wants to go install that network, they're better prepared. If you want to solicit funding, you know what kind of funding you might need in the future. So just discuss resources, human, logistics, and time needed to implement all of these practices. And then summarize and discuss current practices by specifically including their challenges, good and poor practices. So this chapter is mostly going to be a review of what's out there. Chapter 3 is stakeholder data needs. And I know we did not reach out to all these stakeholders through the soil moisture working group, and this table is incomplete. We have a bigger table in the actual document. But we did, the chapter leads on this document are Richard Heim, Zamir Libahova, Mark Brusberg, Vineet Sehgal from TAMO, and John K. I forget what the K stands for, but it's in the document. I'm sorry. So we collected information based on the application, our stakeholders, the accuracy metrics that they use, the kind of data latency they want for their applications, the depth of soil moisture data, the depths from which they want soil moisture data, the units in which they use soil moisture, and then anything else that was pertinent to them. So again, because this document is to serve as a guidance document for operators everywhere, we want to summarize what the stakeholder data needs are. Just to summarize, I think briefly, and this probably needs a little more in-depth looking at, but a lot of our stakeholders want derivatives of volumetric soil moisture. Volumetric soil moisture stays at the core heart of what we want to measure, but they do want derivatives like the equivalent water depth in the root zone, or say the available water content. And I think for everywhere where we're measuring soil moisture, these few parameters of soil properties are probably going to be a must. So site description, people want to know, for example, the US Drought Monitor wants to know if you're using that soil moisture measurement from a station, how far and wide could you apply that to? So site representation description is something that they need. Field capacity and wilting point to get the plant available water. And I've put 2 exclamation marks on field capacity because people are measuring it in multiple different ways. Do we want to go into the details of that in this document is something I was wondering about, and hence I've put those 2 exclamation marks. But again, this is important information that our stakeholders want. Identification of root zone, bulk density, and bulk density throughout the soil profile to make sense of those volumetric measurements, also to convert or to form a relationship between the volumetric and gravimetric when we do calibration and validation. And then site history is something that turned out from this table that people would like to look at. So chapter 4 is perhaps the one that I spent a lot of time on, and we probably need a lot more discussion on it, is site considerations and sensor selection. Site selection is something we'll probably discuss. Units of soil moisture measurement that we need to be reporting, and then how to select a sensor. So for site consideration, what is in the document right now, and this is completely open to critique. So we can do that now or later. I just have 5 minutes. I'm going to speed this up. But what I have in there right now is, again, for a state level measure, this is not planning for the national level, is to first select the land cover based on stakeholder interest. I mean, if you don't have a particular stakeholder, then maybe we don't need to do that. But if there is none, the first level of planning should probably be on precipitation variability. Yes, there are dry downs, and dry downs vary with changes in potential ET, the kind of vegetation there is, what topographic location you're on, and what soils you're on. But once you have that precipitation hit a certain area, there's a step change in the moisture response. So perhaps if you're planning a network like that, and if you understand the precipitation variability, that should be the first level in planning your site. But then further, it should likely be soil-based, and this is based on literature that's been cited in the document. But a way forward could be to use a macro and micro site selection, kind of like what NEON does too. The macro site selection could be a dominant soil series for the area, and this kind of information is available, say, from Surgo. But then at micro site selection could be doing a lot of soil augering, something that Matt Levi will detail in his Appendix A, where you should look for whether the place that you're installing a sensor at, it's not an old road, or it's not got buried soils, or it's not fill material, because even within the area where a lot of the mesonet sites are, there can be variability, as we learned the hard way when we hit an irrigation line while installing our sensors. Topography-wise, possibly flat or mild slope unless dealing with sloping terrains. And again, this is open for discussion. If you don't have the time now, we can do it through the document. So yeah, I put a link there. Sensor selection. So I'm kind of detailing what kind of sensors are available, what are advantages, disadvantages. These are the kind of headings I'm classifying the sensors under. Hopefully this is going to help you pick out the right sensor for the kind of application you need. Quality assurance and quality control. This chapter is also fairly involved. We're going into categories of data errors. So at Synoptic, we saw they have a lot of on-the-fly real-time flags. And those automated flagging is possible for easy to identify errors, but the hard to identify errors where you've got sensor drifting or fouling, we need a little more involved QA/QC for that. So this sort of goes into that as well. Quality control talks about laboratory calibration, field calibration as well. And then I've kind of gone over the automated QC already. What I do have in the outline right now is suggestions for the hard to identify errors or assess them, but I feel like a lot of them may go into the realm that state mesonet operators wouldn't want to deal with. So that is open for discussion because that would involve inter-sensor comparisons with hydrological, long-term hydrological models, just to see what the sensor is producing and if it's realistic or not. But that's something too. I'm going to skip this. It's a lot of text to read. Flagging is something that will be a part of the document. Something to discuss though, do we want to flag a sensor? Do we want to flag a station? Do we want to flag observations? Automated versus manual flagging, what should the data latency be for both? But that's up for discussion. Post-deployment strategies is something that's still being developed, but it is basically field verification of data, upscaling, what we're measuring. And again, I haven't gone into this a whole lot in the document yet, so I'm going to leave that. But the most important thing, and I know I have 2 minutes or probably a slightly little time than that, but the data tiers are important. And based on all the working group meetings and literature research, I've come up with these parameters based on which we could define data tiers. So this is again open for discussion. Is the sensor installed appropriately based on what Todd's document says? Soil moisture, program, and sampling frequency. So Andres has developed a really good platform for figuring that out. Site appropriate sensors, have those been installed or not? Are they calibrated? Do we have well-defined metadata as per Brianna's metadata document? Pedon description, are they flagged as per recommendation? QA/QC, have they been QA/QC'd? Post-deployment strategies, ancillary measurements, have the soil properties been measured? Data latency and long-term availability. So I'm thinking of this as a checklist. If you've got check, 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 and how many of those parameters you check will determine the quality of your soil moisture data. But again, should we define tiers for stations, entire networks, each observation depth, each soil moisture value measured? I think those are still questions that need to be answered and discussed. So I'm going to leave that here. Quickly show you what we've been doing as a show and tell. That's Matt Levi in the hole that he dug. And what Matt's doing is he's doing a show and tell on how to collect soil properties data. So we've collected undisturbed cores from all the way, starting from 5 centimeters, going all the way to 1 meter. So we've done a show and tell like that. Another thing that we're doing is we're doing horizon versus depth sampling of soil. And for probably 2 right now, 2 Georgia soils, very distinct Georgia soils. We're looking at how doing a horizon versus depth-based sampling changes the estimate of available water in the top 1 meter, but we're still processing that data, I think. We've had a wonderful team in the working group, and these are all the contributing members. I think I got everyone's name, but if I didn't, please tell me. We're very, very thankful to everyone who's contributed to this document so far, and it's still open for contribution. I put out a Google link, and Marena will share that. My acknowledgements, I did acknowledge NIDIS. Thank you for funding this effort. Marena, Mike, and Todd, they've been so instrumental in putting this effort together. We've been having planning meetings for each working group meeting, and that's really been very helpful. And Matthew Thibodeau is our awesome field technician who does all of these soil moisture installs for us. So with that, I'm probably out of time. Here are our email addresses. Feel free to contact us. Thank you.
Okay, thanks, Nandita. So we're going to take, if you have any specific questions, clarifying questions right now for Nandita, you could go ahead and raise your hand. But otherwise, if you want to share substantive thoughts, let's wait, or kind of want to probe deeper. Any specific questions? Okay, let me mention that we are going to share around Nandita's PowerPoint, at least. Brianna, I don't know if you have any links on yours, but we'll share Nandita's PowerPoint around so you can have those links to the forms and also be able to look again at some of the information she shared. We have something from the web. Okay, we've got a question, or yeah, comparison with adjacent water table well data should also work. I hope you all know what that question means. Okay, hold on.
That could so comparison with adjacent well water data is something we could consider adding depending on what the connectivity there is. Depending on the soil, that connectivity may be really slow or the response could be really quick, but that's something that we could consider. Thank you.
Okay, again, more questions later, I hope. Let's see, I was going to mention something. Oh yeah, these projects are not just because it was in the strategy document. That was really important, but it was also because this time last year, this community of folks, we had an open discussion of what should we be focusing on this next year, and data quality came to the very top. So you all also participated in making this a priority, and I just want to make sure you knew that. Okay, now Brianna's going to take we just talked about the how, which is a pretty big topic, but there's also some what metadata do we need?
Good afternoon, everybody. Metadata is probably not the most exciting thing you guys have ever talked about, so I'll try to keep you guys engaged and move through this a little bit quickly so we can get to our discussion, so we can get some feedback from you guys, because that's really the purpose of this entire session, is to hear back from the larger community. So as Nandita was working on developing data quality guidelines for soil moisture monitoring stations, I am leading the charge on developing metadata guidelines for soil moisture stations. This is also funded by NOAA and NIDIS. The team that we've been working with, so we had a little bit of a different strategy than Nandita's group. I got started a few months later, so I selected a smaller group of people. So this is the group that I've been working with. You can see they represent some of the state mesonettes, some of the federal agencies, a few academics. So we tried to get a variety of different stakeholders to give input on this. So as Marena just mentioned, at this meeting last year when we were at Ohio State, we had a working lunch, and data quality and setting data quality guidelines was determined to be one of the top priorities of the National Coordinated Soil Moisture Monitoring Network moving forward. So in this past year, we developed these two working groups, and you just heard from Nandita. And now I'll just jump into the metadata stuff. So this is a figure that was taken from a paper that was published in Vedostone Journal, where the NCSMMN Executive Committee sort of outlined their thoughts on metadata and what should be incorporated as standards for metadata for soil moisture monitoring sites. So all of the information that's in the metadata document as it sits right now basically just builds on this outline that was given by the executive committee in this paper. So you can see there are four major categories. We want to know metadata about the network, the overall network. We want to know information about each site. We want to know information about the soil moisture sensors that were used. And then we want to know information about the soils that those sensors were installed in. So now I'm just going to run through some of the details of each of these four categories. First, with regard to the network itself, what is the network's affiliation? You know, some of these networks are managed by federal organizations, others are run by universities, some are by state government agencies, and even some are private. So what is the affiliation of the network itself? What is the mission of the network, or what is the intended data application? Are you looking at surface water forecasting? Are you looking at urban flood prediction? Are you looking at plant water use or drought monitoring? All these different networks have different purposes, and that will shape how the data are collected, what types of sensors are used, et cetera, et cetera. So what are the quality assurance or quality control protocols? This is not us giving a recommendation as to what you should be doing. This is us just telling people, tell the public what it is that you are currently doing. So when you get this raw data in, what are the QA, QC protocols that you're filtering that data through? So we'd like to ask people to publish, if there are any thresholds, if you're removing any data, and then if you have any flags, please clearly document those things somewhere so that users will know what you've done. What installation protocol did you use, including the orientation of the soil moisture sensors? So were they installed horizontally? Were they at an angle, or were they straight down? These are all things that are important when interpreting data. How often does maintenance occur? And then when you do maintenance, what types of things are you looking for? Is there an update schedule for metadata themselves? So for example, some networks will provide a photo of a particular site as part of their metadata. And we want to know, how often is that updated? Because sites can change over time, and it'll be important to document when these metadata are updated. What is the contact information for the network manager? How are the sites communicating with the network manager and or one another? And then what is the frequency of all of your measurement types? So this includes both above ground and below ground data. So if you're measuring soil moisture, tell us how often you're doing that. If you're measuring precipitation, wind speed, relative humidity, how often are those measurements being collected, and are they being aggregated before they're reported? So I have just a few examples here of why site photos are important, and many of you probably know this, but I feel like these are just fun examples. So we would like to have photos before the installation, during the installation, including pictures of the whole pit or trench in which the sensor will be installed. And then once you've put the sensors into the soil, take a photo of that so we can see, what the sensors look like and how the wiring was managed. After you install, what does the site look like after you backfill that soil? If you are able to, seasonal photos are great, especially in terms of looking at plant condition. Also, in some areas, there may be changes in soil condition that may be really important to note. If you decommission a station, you might want to document what that looks like at that time, especially with the second point there. If any of your sensors have been damaged, it's good to take a picture of that just to document what's happened. So Mike mentioned, for those of you that went to the field day yesterday, mentioned the PhenoCam network. So there are some networks that have daily photos. And if you're one of those networks, it would be good to indicate, in which direction those photos are being taken and if the camera angle is tilted at all. And then finally, this should go without saying, but we're including it because we always should. You should always include a name for each site, the date, the sensor depth, and other relevant information when you're naming these photos. So an example of why photos are so important. So this is an example of a station that was installed in my current state of Texas. Currently, there are no photos of these sites. This is just one that was taken by the press. And if I happen to notice that there were some weird things going on with the soil moisture data at this site, I would be able to look at this site photo and say, the soil moisture sensors are installed in a ditch. No wonder I'm getting funny readings. They're probably really overestimating because they're getting a concentrated amount of rainfall after every single event. This is a site that I installed in Oklahoma for my PhD, where we really disturbed the soil in this forested area. So we used a a walk behind trencher to lay down conduit about 20 feet out from our data logger. And then you can see on the floor of the forest right there, it's very disturbed. The soil, you know, we moved a lot of soil, but a year later, this is what that site looked like. So this is just another example of why those seasonal photos might be important, because a site is not going to look the same in the future as it did when you first installed the site. This is just a photo of a soil profile that we recently excavated. Something like this will help someone else see what the soil at the site looked like. And then this is another example. One good thing, if you're installing soil moisture sensors, especially if you're installing multiple types of soil moisture sensors, having a photo like this will help you remember which order you installed them in if you didn't take a picture. So this is one picture that my student was really glad that I took because he didn't write down the order of the sensors. As far as the site information, I've broken these up into some smaller categories. So of course we want to note the station name or ID. A lot of these networks have unique site names that are used within the network that no one else in the world knows what that means. So it's good to have a table of both the full name and if you have a unique station name or ID to include that there. What are the state and county, both the name, the abbreviation, the county name, and then the FIPS code of each site. Of course, the latitude and longitude and the elevation. These are kind of basic. This was an addition by one of our colleagues, Claudia Cotton, who works in mountainous areas. So if you're in an area with some topography, it would be good to mention the slope, aspect, and landform of your site. So the aspect in degrees, the gradient in percentage, and then the shape of the landscape. So there's this helpful picture on the right-hand side. Is it convex, concave? Is it a linear landscape? And then the last part D, is the position. So if you're on a hill slope, I think the soil scientists are probably a little bit more familiar with that diagram. Are you on the summit? Are you at the toe slope, the foot slope, et cetera, et cetera. Other landscape characteristics include land use and land cover. So you might include something like the description of the pixel from the National Land Cover Database. And we noted that it might be useful to mention the information at that site and within, you know, a decent sized area. It says 100 meters here, but you could even go beyond that. A lot of these stations are sort of located very close to an agricultural field, but the sensor itself is installed under grassland, something like that, or even an aerial photo can help with understanding some of these dynamics. Nearby obstructions. So this is similar to what you would see from the World Meteorological, the last word, organization. Thank you. So they make note that you should document any nearby obstructions. So any trees nearby, any buildings, is there a parking lot nearby? How tall is that obstruction and how far away is it from your site? And then finally, we have information on the installation itself, maintenance, and then change over time. So of course, you should always note the installation date, but that can also vary from the data connectivity date. So maybe you install the sensors in the ground on one day and then come back and connect that to a data logger at another time. And then maybe you wait a few weeks or a month to make the data available to the public. And then if you decommission a site, you should note the decommissioning date, or a lot of the time networks will move a site from one location to another. And you should mention the relocation date. There's also a site maintenance record, so noting what day and time someone came out, what they did, if they replaced any sensors, that's really key. And then this was another recommendation that I don't know that I would have thought of, thanks to Claudia Cotton. So especially in areas with topography, there's often erosion and deposition. And if you have sensors installed at specific depths, that depth from the surface will change over time. So in certain instances, it might be important to record sedimentation and or erosion at your specific site. It's also important to note if there are ancillary measurements. So in some networks, sometimes the soil moisture sensors are under bare soil, sometimes they're under grassland, or whatever the native cover is. Sometimes they do both co-located. Often the soil moisture sensors will also give you soil temperature, but sometimes they use separate soil temperature sensors as well. Some sites also collect matrix potential data. And then importantly, if you're using soil moisture information in any sort of irrigation planning or in relation to plant water use, it's really important to have those weather variables. So just a list of the weather variables also recorded at the same site, as well as the height at which those variables are collected, is important. We move on to the soil moisture sensors themselves. I am preaching to the choir. You guys all know there are many, many different types of soil moisture sensors. So it's important to note the number of sensors you installed, the depths that they're located at, what the model and manufacturer are, the calibration type. So most people just use the manufacturer's calibration, but if you've done a site-specific calibration, you should mention that you've done that and the method that you used to do that. So did you do a calibration using field data or in a laboratory, because those will affect the calibration equation itself. Is the date installed different than the deployment date of the station? So this would be like with the RAWS network, for example, they're retrofitting all their stations with soil moisture sensors. So if that soil moisture installation date is later, you should note that. Where are these soil moisture sensors located relative to, if you have a 10-meter tower or a 2-meter tower? Do you have a standardized location? Is it, always to the southeast of that tower? So what is the location of the soil moisture sensors? And then for your specific sensor, what kind of data, what raw data does it produce? And what are the units? You'd be amazed at how many people don't bother to tell you what the units are. It's pretty important. Finally, the soils themselves, you should include the Sergo map unit key. If you're able to, get a full description of the profile or the pedon, the texture in terms of sand, silt, and clay. Another thing that's pretty important, part C, coarse fragments. So if you have any coarse fragments, it's good to measure and report those. Bulk density, soil water retention. So this is where we get a little bit of contention. What points on the curve do we want to report? I left -33 and -1500 just because those are the standards. If we want to argue about that, I'm sure we can. Additional points is available if you want to do more points. Mineralogy of the site is also good, especially for things like shrink swell soils. Having information about the mineralogy itself might help you explain why sometimes you might have erroneous soil moisture readings if the sensor itself doesn't have good contact with the soil. We have the saturated hydraulic conductivity, the aggregate stability, and then again, another great contribution from Claudia. When you're talking about forested areas, you often have a thick organic matter layer. What is the depth of that layer? How much of the area surrounding the site does it cover? What is the source of that organic matter? Is it evergreen? Is it deciduous? Does it cause hydrophobicity? And does it change over time? And then there's also the discussion of whether or not that organic matter layer contributes, whether or not you should consider that as soil or scrape it away and start your sensor depths at the mineral surface. Come back on Thursday for that discussion. Tiering system, like Nandita said, this is kind of to be determined, and we'd like to hear some of your perspectives on what you guys think about a tiering system. Again, we have in mind something like the WMO, they have tier 1 for above ground variables, tier 2, tier 3, and there are specific qualifications that you have to meet to fall into one of those categories. So I think the idea that we have is something similar to that. And I am done.
Okay, any quick clarifying questions? Okay, start here. Go ahead. Mike's gonna get there.
So where will this data be shared? For our sites, for example, a lot of this data would be considered sensitive information, being on an Army installation base. So is this like general public use? Is it going to be like, how is this going to be disseminated so that way we can know how much of this we can actually share about our site data?
I guess we do not really make a recommendation on who shares it, where they share it. I guess the only thing we are recommending is for someone, a stakeholder, to make full use of this data. This is what you could be recording and keeping like a note of, but who you share that information with would still be up to the people collecting the data.
There's some people talk about fuzzing data. So the exact latitude, longitude can be fuzzed. You know, just give 2 decimal points, get you close. But the other information you're collecting could still be provided. And that would be more helpful because sometimes it's not the physical location, but what's the soil texture, serial number, things like that.
Oh, yes, wonderful presentation. I was taking notes just as you were making your list. Such a comprehensive list. I mean, my question that I have and what I would like for you to comment on is that what are the resources and the cost associated with putting together such a comprehensive list?
So that's a great question. And that has been one of the, I think one of the biggest hindrances. And whenever we talk about this, the networks are all saying, we can never afford this. This is never going to happen. But especially when and if we get the tiering system worked out, the idea is that having this tiering system might incentivize getting some of this information. So maybe, you know, as is, your network is tier 3, you know, it's one of the lower tiered networks. But if you get, you know, let's say soil texture data for your sites, that might bump you up to the next tier. So what we're hoping is that some of these networks can take this document to their organizational leaders and say, look, if we do this, it's going to make us look better. Can I get some funding to do this? But you're right. These measurements, to get all of these measurements would be very expensive. And I think it will be important for us to define in these documents, like what is the bare minimum? What is, you know, what is something more robust? And then what is the, you know, the best of the best? But I think that's the direction that we're headed.
And to follow on that, is there a particular source you prefer the data to be from? You mentioned the PEDON, but could a network that doesn't have that information pull Sergo, the nearest grid cell? Would that be, I mean, obviously we want to know where the source of this information came from, like the soil textures and things, but
right. Yeah.
and then we can update that when we get the PEDON information.
Yeah, so it's possible to, you know, just use whatever the map unit description is that, you know, based on GPS location, what the Sergo data says. Some places may also have access to, you know, an NRCS employee that may be able to come survey the site, or if you're at an academic institution, maybe you have a pedologist who would really just love to come and, you know, get their hands dirty. So I don't know that the method itself is what is important, as long as there's, you know, information provided and then you document how you got that information. So for example, when I said the soil textural data, so sand, silt, and clay, there are multiple methods of getting that measurement. Or did you use, you know, the hydrometer method? Did you use the pipette method? I don't really care as long as you tell me what you did.
I just want to add to that just Brianna's, I think, doing this in Texas right now. If for some reason, like there are established mesonettes and they've not collected all the information at the time of installation as per what this guidance document recommends, or we think in general as a community is important, you can go back and collect that information also. And you're doing that in Texas right now. So not all that information has to be collected at the same time.
Okay, we're gonna go to the back.
So having done quite a bit of quality assurance work and collecting data and then installing sensors and so forth hundreds of times, I think there's nothing more valuable when you're doing the QA QC than a soil description. So you get a lot of the stuff that you're talking about, but in the context of the horizonation, that is just as important, I think, as having that information, especially where we don't install sensors according to horizons, or typically networks use fixed depths. It's very, very valuable to know that, you know, maybe your 50 centimeter sensor is just above an argillic horizon. So that's a clay rich horizon that may, you know, it's a lithologic discontinuity and it's going to hold water on initial wettings, for instance, so that it really, really helps, gives you the context to help explain whether a sensor is working exactly as it should or not at all.
Okay.
I couldn't agree more. And that is why we do have the full PED-on description as one of the most important parameters. And the effort that Matt Levi is leading, where we're doing that horizon versus depth-based sampling to make sense of soil moisture readings and what it means in terms of the amount of total water in the root zone, that was exactly driven by this question that we had as well. Yeah. And we've installed sensors that are like at the interface of the horizon to see what that data would look like so that we can have examples to kind of share.
So I just want to say we've obviously got into the conversational questions and conversational part of this. And let's take a few more. And then I don't want to give you guys a chance if you want to focus the conversation on certain points or not. So you're going to drive this a little bit with that microphone. And we're just going to pass around the microphone.
Yeah, I think this is sort of for you, Brianna. I know you mentioned you don't care what kind of method was used, and I know that's not exactly what you mean, but in your documents, actually for both of you, this is a question. Do you think you'll have some minimal level to suggest what would be the best or the better or the standard requirement to use to get at one of the parameters that are needed? I mean, will that sort of information be suggested in there? Now, in the metadata, maybe not so much, but maybe in the requirements document? Because I know you don't want someone to put just any method in there. You need some minimal level of standardization.
Right. So I'll just make a comment real quick. So for example, with the soil texture, like I was talking about earlier, I'm happy with whatever information you can give me. Some information is more than no information, but I would maybe draw the line at something like texture by feel. Maybe I don't want you estimating that way. Some actual sort of laboratory measurement on actual samples would be ideal.
I'm going to read from the chat real quick, just from Tyson Ochsner. In terms of data quality, I think there's a great value post-installation soil sampling to quantify the accuracy of soil moisture data coming from the sensors. So that's a post-install verification, validation, scaling comment.
Maybe I'll address Caroline's comment first, and then come back to this. I guess you probably answered this question, didn't you? You answered the question that Tyson had, or did you not? No.
I was just reading from.
Just reading the
I want to make sure I didn't miss it.
Yeah. So just to answer your question, Caroline, this is where I said that when I started to go into this document, it gets really deep and dark because there's a lot that you can write about, especially for, say, field capacity. I mean, there are different ways to measure it. Tempe cell, what matrix potential to measure it at? Are you using the high prob? You're getting the full retention curve. Are you using undisturbed versus disturbed samples? In the document, I want to recommend undisturbed samples even from the 1 meter depth, because especially for field capacity, you want to preserve that structure. But there will, I still don't know, and this is something that I wanted to maybe ask the community, there needs to be a, like a scope to go over in terms of methods, because each of these methods could get very diverse. So what I think through this document, what we'll ask is you at least list everything out. So there's transparency. There will be some recommendations and guidelines and references that people can reach out to, but the most important thing to make best use of the data is transparency.
So I want to drop another associated topic in the room for us to start thinking about, but we're so far away from it. But I want to talk about soil moisture and soil carbon and the data quality that goes along with that. The Forest Service, we are on a path of defining what is forest soil carbon. How do we want to deal with it? How do we want to monitor it? What do we want to say about it? What is our management? How does our management affect it? We talk a lot as an agency about carbon, and particularly because of our forest inventory and analysis data and our above ground carbon, our knowledge about our above ground carbon for our forests, but we don't talk a lot about our below ground carbon pool. And Rich Poyot and Russ Briggs will be here tomorrow. We have collaborative conversations that we know that we want to link the soil moisture conversation, soil moisture monitoring to soil carbon monitoring and trends. So that's why everything that you've presented about why it's so important to know all these soil properties and characteristics on the landscape about where we're taking this data is so critical for the future and for models in the future that are going to be able to tie the relationship between trends in soil moisture and the soil carbon pool and that trend, and then put management on top of that, including natural management, if you will, like wildfire. And we talk about the carbon cycle. It's so connected, and I appreciate so much of you bringing to light about the soil properties and all these varying characteristics. And then I also wanted to add that we are doing with RAWS, with our Forest Service network for our RAWS network, adding in a lot of those properties into the new fire environment mapping system where you can actually know that for each station. It's like metadata about the station that talks about soil properties. So I just want people to start thinking that it's not just about our soil moisture monitoring, it's also about our soil carbon out there and how we can talk about that too. So thank you.
And I'll just jump in, based on what Stephanie was saying, that the entire purpose of this network, it's a network for the public good. And we all know that there's a ton of soil moisture data available, but if no one knows it exists or has adequate information to use it for, whatever their desired application is, it doesn't really matter how many stations we install. So I think that's one of the driving forces behind both of these documents, is to make sure that the work that we're doing is actually able to be used for the applications that we're talking about.
Hi, thanks for your talk. I was wondering if there's anything in the guidance document that's going to address different, how to deal with different soil types or different soil moisture regimes. So for example, like dealing with Western soils seems vastly different from dealing with soils in Maryland in certain ways. In other ways, really strong baseline metadata seems important all over. So just curious about that.
So in terms of dealing with different soils, for example, just collecting bulk density in sandy soils versus clay soils, we could have differences. There will be some detail into it, but there'll be a lot more references on where you can go and kind of look at it. To the best extent possible, I will summarize them, but then there will be links to where you can go and kind of look at that. What will be in it though is we're soliciting soil moisture data from networks all over. So if there are errors that are specific to a certain soil type, for example, in the sweltering soils, the response of the deeper sensors to rainfall might be quicker than the surface if there are cracks. So we can expect different kinds of errors and different geophysical characteristics. So we'll have examples of those in the document for sure.
And all I'll say is that this is where, instances like this will be where it will be good to be in touch with someone locally who's maybe more familiar with the soils than you are, if these are questions that you have. And just thinking about it now, maybe we could include some resources on how to find a local soil scientist.
I'll make a comment. So for you, It's not Brianna and Nandita saying, well, we really need this data. They're saying the community needs this data. And I'd say the community needs about half of this data. And then the other people that need that data are you. Because I don't think everybody has ever said, gosh, this data looks great. I wonder what the serial number is on my sensor. No one cares. This is data for when something goes wrong or doesn't look right. So, man, this sensor just doesn't look right. I wonder if I got a bad batch of sensors. What's my serial number? Let me go trace that back. I can't go dig up that sensor, then I've lost my in situ time series. So, or, I wonder what was going on. A picture from that year helps that. It's really building your own history so you can go back in time because you're going to get the questions. I have notes of my own that are like, what happened 11 years ago on this experiment, on this day, on this team? And I'm like, I have no idea. So I have to go look at my notes, and I've literally seen notes of flip back to that book and it says sunny. That's what my note is for that day. And that's all I have. So then it takes a long time. And honestly, a lot of the data is not going to have a great return on investment. But so I took a picture. Maybe no one ever looks at that picture if the station works well for a very long time. No one ever cares about my serial numbers. But when you need to know that serial number, you're going to wish you kept it. You're like, oh, it'd take me 5 minutes, 2 minutes to write it down. So half of it's for when things go wrong. And that's for you as a data producer.
I want to second that. And I want to say that if you are a monitoring network operator and if you've got stuff like that, please go ahead, fill that form out, because that's the purpose of chapter 2, just to get all that information that's sitting in your brain and you know this and that lives with you. We want to bring all of that knowledge out and put it in the guidance document. So go ahead and fill that form out, please.
Thank you. It was a great talk. And I was wondering if you put any thought on the format on the metadata. It seems that it's a very unstructured collection of information. And I wonder how is it, we first start to document that and then how we share it. Particularly, someone uses Neon frequently. I find it extremely useful, but very overwhelming. And so when you download one file, you have 3 or 4 other files with just metadata. So
yes, that's a fantastic question and something we have chosen not to address. Yeah, Marena, go for it.
Yeah, just want to sort of add on to that. Okay, so this is actually, you would think, on the one hand, a very simple task, write down on paper, conditions for data quality, write down on paper, the actual metadata we want to do, but it ends up being, as you could, I think in a sense, maybe you already knew this, extremely daunting. I mean, how far down do we go? How much detail do we include? How do we calibrate what's really important versus not, tier, et cetera? So that's all out there. But we don't want to have the perfect be the enemy of the good. One of the things that I've noticed coming into this community, your guys' community, is that you already maybe don't say it, but you're doing it all the time. You're bootstrapping, you're doing something this way. And then we've learned from that, we're going to do a little bit better this way. And you're just kind of building. And that's what we're seeing this document. And in fact, the installation protocol is the same thing, right? For right now, this is our best sense of how to do this. For right now, this is our best sense of what constitutes data quality. But we acknowledge, and you guys are going to put it in literally these words in the documents. We acknowledge that this isn't the end of the story, and you all can help us. You hear, and anybody who reads them can help us next step. And it just occurred to me, since we're not in the new world where we can do links and stuff, we ought to include a link, hot link, well, any electronic version to some kind of form where people can fill out and comment. Yeah. Okay. Hold on.
I think it's a great idea because I've done instrumentation 25 years of my life, and the ROI is the time you save, especially when you have transition of staff and other people come in. And this is one of the things we at Synoptic also want to do in our platform. Our platform should be able to tell you when you install the battery, what serial number, even an approximate cost, so it can help you budget it in the future and send you a reminder 3 years later that your batteries are degrading and your soil moisture network needs calibration. So we would love to work with you. I know we're working on several things, but this is exactly what we want our data providers to have it so they can manage and maintain their network. But great presentation. Thank you so much.
So I guess mine is more of a question of clarification. So once a provider fills out all the metadata and everything like that, do they send it back to someone, or do they just keep it? And I guess, how do you reach out for the metadata of a site? Do you have to find out who owns it and then talk to them, or is there going to be like a database of metadata somewhere? Or
Yeah, so great question. Right now, there isn't a plan in place to, you know, centralize all of this information. The goal with these documents is to provide recommendations, just provide recommendations for these networks about the types of metadata that are valuable to the community. And ideally, I would like to see those posted online somewhere so that the public can use them. But like the National Coordinated Soil Moisture Monitoring Network doesn't intend to be like gathering this information from all the different networks. It's going to be the onus is going to be on the network to do what they want with our documents.
so just be more of like a point of contact associated with whatever station or network, and then someone can reach out to them for that metadata.
Right, yes. So most of these networks have a web page where you can maybe go look at the data or download the data. Ideally, the metadata would be, you know, linked somewhere on that web page.
My thoughts on this were just that, I was fortunate when I put some of my sensors in the ground that the NRCS was there on site helping me. And they have their own standard field forms for a lot of this. And so, possibly rather than reinventing the wheel, there might be some resources out there that you can utilize that are already, available, that you could provide links to. Or, if you did want to reinvent the wheel, there's some really nice tools out there now, like Survey 123 apps that you could put together that would be standardized so that everybody had the same format for a field form where they just, their tablet or their phone, they could just kind of click through it. And then you'd have the data electronically, at least for the field stuff. And then if you had to update it with like particle size or anything like that in the future with lab data, you could do so at that time.
It's an excellent suggestion. Yeah, we'll definitely take that into account.
In a way, this group, NCSMN, is founded on collecting resources and making them available to everyone because everyone has these problems. So a survey that one group has, let's promote that survey. Let's make available GitHub repositories that have already done the thing you're trying to find and just don't have access to. Let's put the thematic data and software and tips and tools together so that people know where to find it and then can implement it at their own location, with the hope of eventually having them be able to be ingested into a common format that would be more searchable and easy for people to bring data together into a harmonized concept, which is an ultimate goal of ours.
I just wanted to kind of make a connection between a couple of topics here. One with respect to the recommendations. I think part of the effort here is to sort of have an unbiased approach to categorizing the information that is collected and make recommendations, maybe to Caroline's point about what is the recommendation? I think that's where the topic of tiers may come in, where we can use the tiering system to say, these are the best of the best. And then, this is sort of the bare minimum. And so this unbiased effort will help the whole community by having folks strive to have a higher tier in their data and seek funding from their programs or elsewhere to try to make more out of the data that we have.
Thanks, Matt. If you have more questions, feel free and you can keep asking questions as you go. But since there's a little break, maybe we can talk about site selection. I know I kind of went over that site selection criteria really fast, but do people here, obviously we've got years and years of experience. Do you have thoughts on how you select sites? What are the best ways in which you determine what's a good site for your soil moisture monitoring station? Or just curious how you do that. Just thoughts, basically.
Raise your hand high. I'm sorry. We're thinking it might be worth getting your presentation back. We're going to get Brianna's, Nandita's presentation back up. Yes, that helps.
I think one thing I've learned about site selection for our network, and this might be very different for folks working in the agricultural community, but if you're looking to put your sites on public land, I highly recommend starting with community engagement and with outreach to groups who do own property, whether it's the county or the city or the state, before you ever start with the other components of your site selection so that you know what you're going to have to choose from. Because it can be easy to try and work the other way and end up in a situation where all of your ideal spots are spots you can't seem to get permission for. So don't undervalue the community connections as you're considering where to site things.
One of the things that drives site selection is, why am I collecting this data? And I talked about it yesterday, not everybody was here. There are different funding groups. Those funding groups have their reasons. And those are the purposes that must be met as a minimum to keep getting funded. So if you have an emergency management purview, you need to have low latency. And you need to have meaningful data that's going to inform decision makers about flood stage, reservoir stage, if that's what you're monitoring, road conditions, if you're transportation focused. So there's multi-purpose, but then often our funding is singular. So that drives our siting decisions, and we make do with what's left. Adding on top of that long-term access to locations, changing landowners. And I asked this question yesterday, how many people have had a landowner die on them? Multiple times. Like I've had like 4 landowners pass away on me. So, these things, and that's only like a 4-year study. Imagine the 20-year studies. So those are some of the issues that we see with siting. Any other experiences or things that are unique possibly to your use or need?
So one of the reasons that SCAN has actually shrunk between presentations, earlier on, you saw that the network was at 240, 245, and now we're back up to 210, is because of site selection rigor not being adhered to. And basically what I've decided is if somebody comes to me and says, wouldn't it be cool if, we put in a site here, I automatically discount that location and we move on to something else, because that usually means that it's a unique place that's difficult to get to, and or they just want to get there regularly or so on. And we had several of those in SCAN. Several were disconnected for different reasons, or ended for different reasons. Ownership changes like Mike just mentioned, and land use changes and so forth. But the very cool locations tend to be very difficult to actually effectively maintain and keep working. For instance, one on top of Hayford Peak, just east of Las Vegas. It was a very cool location, but it was a helicopter only site, and it got hit by lightning less than a week after we visited it 4 times. So I think practicality has to drive the final decision.
But you get frequent flyer miles on the helicopter, right?
So for picking your sites, a lot of the time you might be given a field to study like I have, but there's still some selection for picking the exact location of your station within the field. So I try and pick somewhere that's easy to get to, and if a tall crop like corn is growing, somewhere that's memorable, like looking for landmarks around the edge of the field for where to enter, and also somewhere that tractors and combines don't like to run over. I'm trying to find their previous tracks because they like to go over the same places multiple times. So somewhere out of the way for farm management and somewhere that's recognizable for the people going to the station.
while Ben's getting, I'm famous for giving directions of go down, turn left past that old barn. It burned down a couple of years ago. You won't see it now. But yeah, it was there. And people go, I'm never going to be able to find that. So good directions, landmarks, things like that are useful.
Yeah, so I guess I'm kind of in a unique situation where I'm one of these Forest Service people with, we deal with mountains and stuff like that. And we'll see a little bit tomorrow. I'll show, depending on what landform you choose, the drainage patterns and the redistribution of soil moisture laterally and vertically can be pretty dramatic. So, not everybody has that problem, obviously, but, thinking about what's representative, of the area you're trying to study, what is, don't pick a unique landform, obviously, or something like the ditch that you showed earlier. It's just making sure that you're on a site that's really representative of what it is you're trying to characterize.
I think that's such an excellent point. I struggled with it myself when I was putting this in there, and I thought there's going to be a lot more discussion on it. So what I have here is possibly flat or mild slopes because they'll be easily accessible, you'll be able to maintain them. But truly, if that is not representative of where you want it to be, safely where you can put it in a representative area topographically would be useful. But another thing that I thought of when I was kind of putting this together was, what is it, and this is something I've kind of worked on when I did my PhD, what is it that's really driving the variability? With topography, is that variability predictable? So for example, if you did have a good elevation map and you could figure out the topography of the region, and if you've put your sensor, say, on a mildly flat or possibly flat or mildly sloping area, would you be able to make some sort of inference in terms of whether something down the valley is wetter or drier, wetter in this case? So that may still make the data that you're collecting on a possibly flat area, which is easier to access, maintain, etc., useful as opposed to being on a slope, which may be harder to maintain. And hence that line down there. So in the document, the way it's drafted now, and it's obviously open to comments based on your experience, is I say if you can account for if you can account for how soil moisture may vary as a function of vegetation or topography, then select an area that's easier to maintain, and the soil type, the soil series should drive the variability of where you should install the sensors. But again, yeah, that's open to discussion. Mike.
Another consideration that we've ran into, having a network that's almost 30 years on now, is that many years ago, when some of these sites were established, what was rural then is no longer rural now. So always keep in mind, long-term, how close are you to potential development areas and how that will affect if you do plan on having continuity in those sites.
We're at 2:00 now, I'm not sure.
Yeah, my comment was, it has to do with selecting like the land cover based upon stakeholders' interest. What if the stakeholders' interest is unrealistic? I mean, in terms of meeting the condition for soil moisture measurements. I mean, how do you relate to them if you know that what they are asking for is just unrealistic?
Be able to pay for what they want, I guess. Unrealistic expectations, unrealistic cost estimates.
Okay, did you want to touch on the tiers at all? We really are almost out of time, but
Tiers was supposed to be an in-depth discussion. I don't know if you have the time for that, but again, this is all available to you. So feel free to send emails to any one of us, Brianna, Matt, me, Pam, just send an email and we can get in touch with you. The document is open and feel free to make comments, put your names down there so that we know who's made the comment and we can reach out to you. But yeah, thank you for that engaging discussion.
okay, yeah, thanks, everybody. Let's give a round of applause to ourselves. Brianna, thank you. Okay, we got a half an hour break, 2:30 was when we'll be back for, can't remember what, a little bit more on data quality, some specific projects relating to assessing data quality.